Hello dear students. In the last lecture we had discussed the introductory part of analysis of frames with different steps. So today we'll see a numerical on frame. So what is the given numerical is determine the reactions at internal hinge for the frame loaded and supported as shown in figure. So what is given in the figure here is there are two frames. ACE is one frame, DCB is the other frame, and the respective distances from C for the both frames from the ends are given, that is 1.2 meter, 1.2 meter from A and B, 1.2 meter from E and 1.2 meter from B up to the center here, center hinge. So as we discussed in the previous lecture, what will be our step number 1? In the step number 1, we have to consider the entire frame together. So considering the entire frame, in the step number 1, I will draw the free body diagram. So in the free body diagram, what you have to show? Wherever there are supports, there are reactions. So you can see at A, it is a hinge support which consists of two reactions. One is horizontal AX, other is vertical AY. At B, it's a hinge support, so again two reactions. And these are the two external loadings given in the diagram. And these are the respective distances from the ends. So after completing the free body diagram, next step will be applying the conditions of equilibrium on the entire free body diagram. So on this entire free body diagram, first I will consider moment at A. So considering moment at A equal to 0, which is a condition of equilibrium, yes, now we'll see how the reactions forces will be acting at A. So at A you can see AX and AY are passing through the A itself. So what is the perpendicular distance? It is 0. So moment of these two forces will be 0. Next, BX, you can see BX line of action is passing through the point A. It is passing through point A whose perpendicular distance is 0. So the force will come and act about that point itself. So BX moment will be 0. Its perpendicular distance is 0. Next, BY is acting in a anti-clockwise direction, covering a perpendicular distance of 1.2 plus 1.2, that is 2.4. So by into 2.4, it is acting in an anti-clockwise direction, so it is positive according to my conventions. You can consider it vice versa also. Next, now 100 Newton at E. So it is acting in a clockwise direction, force is vertical, so distance will be horizontal. So vertical force, horizontal distance, so it will come and act in a clockwise direction. So clockwise I will consider negative 100 into 2.4. 100 is the force and distance is 2.4. Next, at D, 100 Newton moment at A will be acting in a clockwise direction. So 100 into force is horizontal, so distance is vertical. So horizontal 100 Newton force, its perpendicular distance is 2.4 equated to 0. From this, by calculations, we'll get value of By, which is 200 Newton. Next, summation of Fy is equal to 0. So on the entire frame, what is summation of Fy? Sum of all the vertical forces. So the vertical forces here are, yes, Ay, which is acting upwards. So plus Ay plus By and minus 100 equated to 0. So what will get equation is Ay plus By we already know. Substitute that here. That is 200 minus 100 equal to 0. So from this we'll get value of Ay, which is 100 Newton negative. So I have shown a arrow downwards here. Next, take summation of Fx is equal to 0. By taking Fx is equal to 0, Ax positive towards right plus Bx positive, it is acting towards right, then 100 Newton at D, it is acting towards right, so positive, equated to 0. Now there are two unknowns, keep as it is and name it as equation number 1. Now in the next step, yes, step number 3, as we discussed in the previous lecture, what you have to do is, now we are going to separate both the frames. So I will draw separate free body diagram for frame ACE. So at E a force is given, show it as it is 100. Now at C you can see C was a common joint for both the frames. So common joint always consists of 4 reactions which are going to balance the entire frame. So the 4 reactions are horizontal Cx, this is horizontal Cx, equal and opposite on both the frames. Similarly, 2 vertical reactions are there, one is acting upwards, the other is acting downwards. So in total these 4 reactions are going to balance that common joint C, which are the unknown force we have to calculate. So at E force is given. Now similarly draw the free body diagram of DCE. So at DCE, yes, there were 2 reactions which already we have calculated, one that is By. I have shown here 200 Newton. Bx is unknown. These 2 forces are unknown, and this is a external loading and the respective distances. So once you have completed with drawing the free body diagram for both the frames separately, the next step number 4 is consider any one frame and apply all the 3 conditions of equilibrium. So now first I will consider the frame ACE. So on ACE I will use the first condition, summation of m about C equal to 0. So if I take summation of m about C here, yes, these 2 forces are passing through that point itself, so they will come and act at there itself, so their moment will be 0. So Cx and Cy moment will be 0. Next, Ax is acting in an anti-clockwise direction, force is horizontal whose distance is vertical. So Ax is acting in an anti-clockwise, so plus Ax into 1.2. 100 is again acting in a clockwise direction only. Force is vertical, distance is horizontal from C point. I have shown the perpendicular distance in the free body diagram here. So it will act in a clockwise direction, vertical force का horizontal reaction. So clockwise, yes, is clockwise. So I can consider it negative, 100 into 1.2. Next, this 100 Newton force, again it will come and act at C in a clockwise direction. So clockwise direction sign convention is again negative. So 100 into 1.2 equal to 0. Okay, so from this you'll get the value of Ax by calculation, that is 0. Next, summation of Fx is equal to 0 on this frame itself, ACE. So on ACE, which are the horizontal forces? Ax, which is acting towards right, positive, then Cx towards right, positive, equated to 0. As we know that Ax is equal to 0, substitute this value in this equation here, we'll get Cx also equal to 0. Hence the 2 answers. Next, step number 3, summation of Fy is equal to 0. So what is summation of Fy here? Vertical forces 100. Yes, this 100 is acting downwards. So minus plus Cy is a vertical force, Cy, and the other force, actually I have shown here it is upwards, but the calculations in the previous step it is negative, so it is downwards. So I have considered here minus 100. So if you have got in the previous step this is acting downwards minus, in the free body diagram you can show as it is that it is acting downwards only. So according to that you will consider the signs here. So equate it to 0. So from this Cy is equal to 200 Newton. So what is the remaining value still now is Bx is yet to be calculated. So what you can do here is you have got the value of Ax which is equal to 0. So in the previous step, in the equation number 1, you can substitute the value of Ax is equal to 0. So that you will get the value of Bx which is equal to minus 100, that is downwards. So hence we have got all the support reactions. If not any values are remaining, further what you can do here is again consider DCE frame, and on that frame again apply all these 3 steps. So you have to repeat this same procedure on this frame until you get all the values of the support reactions. So hence numerical is completed.